Hey guys, welcome back for Learning Target 8D Part 2. Again, we're continuing to work on writing and graphing equations in slope-intercept form. Alright, and so this is where we are in our unit. Again, this is our second day of 8D, which is our first learning target for the second half of Chapter 8. Okay, so as a reminder from what we talked about yesterday, slope-intercept form looks like y equals mx plus b, where m is your slope of your line, so the coefficient in front of x is your slope, and then the number either being added or subtracted is your y-intercept. And so we talked quite a bit about how you always have to look in front of the number that's your y-intercept to make sure you know if it's positive or negative. Okay, so what we're going to focus on today is working with slope-intercept form and graphs. And so can we look at a graph and write the equation, and vice versa, can we start with an equation and create the graph based on slope-intercept form? So if I gave you guys this graph and I said find the equation, write it in slope-intercept form, the first thing that we're going to want to do is start by identifying what is our y-intercept and what is our slope. And so when I look at this graph, I look at my y-axis and I can see that my line is crossing my y-axis right there at positive 2. So that means that my y-intercept is going to be 2. And then to calculate the slope, if you remember back to the first half of Chapter 8, we want to count the rise and the run. And so looking at this graph, I see that this line is going down from left to right, and so I know it's going to have a negative slope, but I need a second point that I can use to count the rise and the run. And so remember that we want to pick a point that we know the coordinates of. So for example, like this point right here is not super helpful, right? I don't know what the numbers are there, so it's hard to count how far up, how far over. However, it looks like this point down here is a nice one, so that's at 4, -1. And so I can use that as a second point on the line. And so between these 2 points, it looks like I need to go down vertically 1, 2, 3 units, and then moving across horizontally 1, 2, 3, 4 units. And so that slope ratio is going to be -3 to 4. Because again, it should be a negative slope. Down 3 is -3. To the right 4 is +4. So -3/4. And we had said that our y-intercept was at +2. So once we can pick out those two pieces of information, which again, you guys were doing that back in the first half of Chapter 8, now it's just a matter of writing the equation. So if y equals mx plus b, then y is equal to -3/4 x plus 2. And so it's just plugging those pieces in, and then you have your equation for your line. Okay, let's try another one here. So here's our new line. Let's start by identifying what do you guys see as our y-intercept. Okay, hopefully you said our y-intercept is down here at -2. And then let's find another point that we can use. I'm thinking this one right here looks pretty good at 4, -1. And so counting the slope, please record what you think the slope of this line is. Okay, hopefully you said that we're going to go up 1 and to the right 4, so that's a slope of +1/4. We had said our y-intercept was at -2, and so the equation of the line now should look like y equals 1/4 x plus -2, or y equals 1/4 x minus 2, because remember we'll simplify that plus -2 into just -2. Alright, what about a horizontal line? What would happen if we tried to write the equation here? Well, when I think about my y-intercept, I'm going to start that the same way. So I can see it's crossing the y-axis right here at +3. And we know that the slope of a horizontal line is going to be equal to 0. Now I could pick a second point, right? And I could calculate it by saying my rise would be 0, my run would be 6. 0 divided by 6 is still just a slope of 0. So slope of 0, y-intercept we said was 3. And so when we imagine plugging that into our equation, y equals 0x plus 3, doesn't matter what x is, 0 times anything is 0, so that entire term falls away, and we're left with the equation y equals 3. Okay, so now that we've had some practice reading or looking at a graph and coming up with the equation for the line, now let's see if we can make the graph based on the equation. So here are the steps if you want to graph an equation using slope-intercept form. Step 1 would be to identify and then plot the y-intercept. So that's your starting point. Step 2 is going to be use the slope to find another point on the line. So think about your slope as that ratio of rise to run and use that to find another point. And then once you have at least 2 points, then you can draw the line going through them. All right, so let's look at this example. So let's graph the equation y equals 1/2 x plus 3. So first thing I'm going to do is I'm going to think about what's my slope, what's my y-intercept. So my slope is 1/2, my y-intercept is positive 3. And so step one then, after we've identified that, is we're going to plot our y-intercept. So at positive 3 on my graph, I'm going to put my first point. My slope then is positive 1/2, so that's a ratio rise to run, up 1 over 2 to the right. So I'm going to move up 1 and over 2 to the right, and that should be where the next point on the line is. Now I could continue that, and I could go, once again, up 1 and over 2 and put another point, up 1, over 2, put another point. All of these points are going to lie in a straight line, and then I can use my straight edge and draw the line between them. All right, let's try another one. If y equals 2x plus 5, all right, take a second here. What's the slope and what is the y-intercept of that line? Okay, hopefully you said slope of 2, y-intercept of 5. For the slope though, let's think of that as a ratio, right? So I can always make a number a fraction by thinking of it as a number over 1. So slope becomes 2 over 1. My y-intercept was going to be 5. And so it's important to think of our slope as a ratio so that as we make our movement to our next point, we have both numbers, a rise and a run. So starting by plotting our y-intercept is at positive 5, so that's going to be up here. And then my slope of 2 over 1 means that I'm going to go up 2 and 1 to the right. Or another option would be that 2 negatives make a positive, so I could go down 2 and 1 to the left. Either way, the overall effect is that I'm going to have a line that is increasing from left to right and would look something like that. Okay, let's try one more here. Let's graph the equation y equals negative 3/2 x. Okay, so I see a slope of negative 3 over 2, and my y-intercept, there's nothing being added or subtracted here, and so that means that my y-intercept is going to be 0. And so I'm going to start with my y-intercept at the origin, and then a slope of negative 3/2, that means that I should have a decreasing line. It's a negative slope. So I can either come down 3 as a negative 3 and then over 2 to the right, or another option would be to go up positive 3 but then negative 2 to the left. And so you can imagine again that both of those points are going to create a straight line with the one that's already there. And so I believe I plotted this one, so down 3, over 2 to the right, and then was able to draw my line in. But again, going up 3 and 2 to the left will achieve the same effect. Okay, and so for our next example, when we look at our equation that we're being asked to graph, we have negative x plus y is equal to 6. And so I'm hoping that you guys are looking at that and thinking, well, that doesn't look like y equals mx plus b. That's not actually in slope-intercept form. And so if you don't have an equation in slope-intercept form, you can't actually identify the slope and the y-intercept until you do some rearranging. So I need to get y by itself here. And so when we think about, line down the middle, how am I going to get y by itself? I need to get rid of this negative x. I need to move that to the other side. And so to do that, I'm going to add x to both sides of my equation. And doing that is going to allow me to cancel out that term. And so I'm left with y by itself on the left side equals 6 plus x, or I could write it as y equals x plus 6. And so, again, I'm rearranging it to be in slope-intercept form so that I can now identify my slope is going to be positive 1. If there's no coefficient written there, then we can mentally put a 1 in, and I'm going to then take that one step further and make that a ratio. So I'm going to think of that slope as being 1 over 1. And my y-intercept is going to be positive 6. Okay, so I'm going to graph my y-intercept up here at positive 6 first. And then a slope of 1 over 1 means I can either go up 1 and to the right 1 to create a positive slope, or I can come down negative 1, left negative 1, because 2 negatives make a positive. And again, from that point, up 1 to the right 1, up 1 to the right 1. And so once you have 2 points, then we can draw the line between them. All right, so we again just went through how do we write the equation based on the graph and how do we create the graph based on the equation. And so to wrap up for today, if you could record something that you either learned or were reminded of and any questions that you have. That'll be it for today. Thanks for watching.